Okay, in this question, we have to check the different cases and we have to see if they are the part 1 of the Newton's law, Newton's first law, or part 2 of the Newton's first law. Part 1 of the law says that object at rest remains at rest, and part 2 says that object in motion remains in motion. So let us check the A part. A food particle stuck to the hand is removed by shaking hand. So this is correct because when you start to move the hand, when you just start to move the hand, the food is not removed immediately because it is stuck there. So when you move hand with very high speed and then you suddenly stop your hand, the food has inertia of motion. It still wants to move. So the food particle will keep on moving and the hand is suddenly stopped. So that is the part 2 of the law. So it is correct. We want part 2 in the question. Now if you check the B option, a laptop lying on a table keeps lying on a table. So it will remain at rest. It was at rest. So that's the part 1. It's not part 2. So C is a coin rolled on the ground keeps rolling until it collides with the wall. So the object in motion remains in motion. So this is correct, part 2 of the law. D is a train bogie after getting detached from running train engine keeps moving for some time. So it was in motion, it will be in motion. So part 2 of the law. He says that an apple detached from apple tree starts falling downwards. First of all, it's not even inertia now because there is some external force and it will accelerate now. So he is not even the first uh, or not even the second. So object at rest is not being at rest, it is actually coming into motion now. And the second law is also not correct. It was not in motion already. It's not like it was in motion, it is continuing its motion. So this is not the case of inertia at all. So E is not correct. So A, C and D, 3 are correct. So option number C is correct answer. In this question, uh, every action has equal and opposite reaction. That's the Newton's third law. So we just have to check in how many following situations Newton's third law is applicable. The first law says, the first statement says, a person punches tummy of a person with his fists. So yes, a person punches tummy and tummy also applies force on the fist. So this is correct. Now B is tiny moon is being pulled by gigantic earth. Yes, this is also action reaction. The force on moon due to earth is action. The force on earth due to moon is reaction. The force on earth due to moon causes tides. So the earth is also experiencing the force due to moon. Now C option is two palms colliding when doing high five. Yes, both are applying forces on each other. And so C is also correct. And D says that massaging the feet with palm. So yes, force felt by palm due to feet is action, let us say, and the force felt by feet due to palm is reaction, let us say. Anything can be action, anything can be action because they are simultaneous. They will act at the same time. It is also action reaction. And he says a person attracted by earth and earth in turn also attracted by person. Yes, that is also action reaction pair. Actually, the earth is also getting attracted by a person, but earth is so massive, that's why earth doesn't do any motion because F is equal to ma, and the mass of earth is so high, acceleration is so low for the same force. So action reaction is still there. For every action there is equal and opposite reaction. So all 5 are correct. So option number D is the correct answer. So in this question, air hockey game, the A part, the A statement says that the purpose of air is to cool the table. It's not that actually. To reduce the friction between the disc and table, we are just breaking the contact and the air does that. So that's the purpose of air, not to cool. So A is not correct. B says that a friction between two solid objects is a contact force and due to air the contact is broken. Yes, the friction between two objects is contact force. Without contact, there can't be any friction. Now, because of air, the disc and table contact is broken. So, we want to reduce the friction, and that's why the contact is broken because of air. So, B is correct statement. Once the air has stopped, the disc stops after a few seconds, and the friction also stops. Yes, when the disc is moving, there is a friction force. When the disc stops, the friction is also stopping because there is no need of friction when the disc is not sliding over the table. So C is also correct. When the disc, when the air stopped and the disc is decelerating, then the friction force will be opposite. So the kinetic friction will be opposite to the direction of motion, and that's why it is decelerating. So D option is also correct. So 3 statements are correct. So option number C is correct for this question. In this question, we have to check the examples of kinetic friction in action. So when two surfaces are sliding related to each other, there will be kinetic friction. A mobile phone sliding on a floor decelerates and stops. So it is sliding, it is the kinetic friction. An object kept on a rough and steep inclined plane starts sliding down. And if it is sliding on an inclined plane, it is a kinetic friction. A mobile phone kept over a notebook starts moving along with the notebook with same exact motion as that of the notebook. So it is a notebook and it is a mobile phone, and if we apply some force on notebook, both will move with some acceleration a meter per second square. So if both are moving with same velocity and same acceleration, there is no relative motion. So basically there is no sliding happening between these surfaces. And that's why it is not kinetic friction. It is actually a static friction. The friction acting when there is no relative motion is static friction. For example, if you keep some block and apply some force and the block is not moving, the friction force is acting in backward direction to cancel out this external force. And that is static friction because the block is not moving relative to this surface. Let us check the option number D, the statement D. Okay, it's actually statement 1, statement 2, statement 3, and let us check statement 4 now. Friction felt by stationary whiteboard when it is rubbed with duster. This is a kinetic friction. We just have to check if the sliding is happening between the surfaces. So there is a relative motion, it's kinetic friction. Let us check the fifth statement. The friction on stationary matchbox and the matchstick is rubbed. So again, sliding is happening, relative motion is there. So it is a kinetic friction. Person walks normally on a rough horizontal surface. Now, sixth is not kinetic friction. When the person is walking normally, he is not sliding his legs against the ground. The force provided by the rough surface is actually static friction. It is not sliding, so it's not a kinetic friction. That's why the kinetic friction is also called as sliding friction also. So four statements are correct. That means the C option is correct. So in this question, Sham is here, Ram is here, this is 20 meters, this is 30 meters, this is river, this is moving with 15 meter per second and this is moving with 3 meter per second. Ram wants to escape from Sham. He needs to reach the boat before Sham could catch him. At the moment shown, their speed and distance are given. Sham is already running with highest possible speed. So what should be the acceleration of Ram from this moment onward so that he can be safe? So how much time the Sham will take to reach the river? The distance is 50 from here to here upon speed is 15. So distance by speed is time. So it is coming out to be 10 by 3 seconds. So in 10 by 3 seconds, the Sham will reach here and the Ram should just reach there so that the Sham can't catch him. So in 10 by 3 seconds, the Ram will cover 30 meters with initial speed of 3 meters per second. So can we use the formula S is equal to ut plus half at square. So 30 is equal to ut 3 into 10 by 3 plus half into acceleration a into t square, which is let us say 100 by 9. So this comes out to be 20 is equal to a into 100 by 18. So a is equal to 18 by 5, which is coming out to be 3.6 meter per second square. So if the acceleration is 3.6 meter per second square and the initial speed is this, then in 10 by 3 seconds the Ram will reach here. If the acceleration is more than this, then it will take less time than 10 by 3. If the acceleration is less, if the acceleration is more than this, then the time will be less than 10 by 3 seconds, and he can before 10 by 3 seconds he'll be here and then he will be safe from Sham. Okay, and if the acceleration is less than this, then the time taken will be more. So in 10 by 3 seconds he will not reach there, he will be here somewhere, and the Sham is reaching river at 10 by 3 seconds, right? So now before 10 by 3 seconds itself, before that this time actually, right, at 10 by 3 seconds the Ram will reach here, let us say in hypothetical case, and Sham will reach here. So basically before 10 by 3 seconds itself, the Ram will actually, Ram is overtaking Sham. Sorry, the Sham is overtaking Ram. So he will catch them in that case if the acceleration is less than 3.6. The minimum acceleration should be 3.6 meter per second square, and that is option number C. So in this question, this is some circus, and this is Ram's house, and this is Sham's house, and this is 500 meters, this is 300 meters, this is 400 meters. Now, if Sham goes directly to the circus, he would occupy his seat 15 minutes before the show starts. So, time taken by Sham, let us say the speed of Sham is obviously Vs and the speed of Ram is Vr. So, how much time Sham will take to directly go to the circus? Time is equal to distance by speed. So this much time he will take, and he will occupy his seat 15 minutes before the show starts. That means if he leaves at time t is equal to 0, let us say in first case, let us say this is my first case while going from here to here, the first case. So in first case, if he starts at time t is equal to 0 in the clock, let us say our clock starts at t is equal to 0, then he will reach at this time 400 by Vs time. Okay, units will take care of themselves. We'll just measure the distances in meters and speed in uh, meter per minute and time in minutes. So this is the time the Sham will take from going to here to here. So uh, when the time is this much in the clock, he will reach there, and he's 15 minutes early, right? So basically, show will start at 400 by Vs plus 15. At this time, show starts. Okay, that's what we got from here. Then instead he went, now in second case, he goes to Ram's house. Let's say this is the second case. Okay, who is going? Sham is going. So in second case, he went to Ram's house, but upon reaching his house, Ram's mother told that Ram already left 10 minutes ago. Without wasting time, Sham went to circus, but he was late by 25 minutes. See, okay, let us say in second case, he again starts at t is equal to 0, and he goes there, he gets some information, and he goes there. So basically, he's directly going 800 meters without wasting any time. So the time he's taking now is 800 by Vs, and he's late by 25 minutes. So the time in the clock is this when he's reaching here, following this path, and he's late by 25 minutes. So the show has started at this time. Show starts. So basically, show starts at this time, and both times are equal in the clock. So 800 by Vs minus 25 is equal to 400 by Vs plus 15. So what are we getting from here? 400 by Vs on left hand side is equal to 40. Right? So 400 by Vs on left hand side is equal to 40. Then Vs comes out to be 10 meter per minute. So that is the velocity or the speed of Sham. Now let us check. Okay, now let us check about Ram. Okay, now at what time the Sham will come here, right? At what time the Sham will come here? If he starts at t is equal to 0, he will come at 500 by Vs time. And his mother told that Ram has left at 500 by Vs minus 10 then. So Ram leaves at what time in the clock? 500 by Vs minus 10. At this time, okay, so at this time, what will happen? The Ram leaves. Okay, and how much time the Ram takes now? Let me indicate in blue. This is the Ram. How much time the Ram takes from here now? Right. So he will take time is equal to distance by Vr. He will take this much time to go from here to here, and then he will reach the show at time. So he starts at this time. Ram starts at this time and take this much time and reaches here. So the time in the clock was 500 by Vs minus 10, plus the Ram will take 300 by Vr time obviously, and he will reach the show at correct time, which is actually 400 by Vs plus 50. The show starts at this time. So we can just keep Vs as 10 now, So 500 by 10 minus 10 plus 300 by VR is equal to 400 by 10 plus 15. So we can just cancel this and we can just say 50 minus 10 is 40 plus 300 by VR is equal to 40 plus 15. We can cancel out this 40 and 40 and we'll get VR is equal to 300 by 15, which is equal to 20 meters per minute. So the ratio of velocity or speed of Ram by speed of Sham is 20 by 10, which is 2 is to 1. So option number B is correct for this sixth question. This question asks, in above question, in sixth question, what is the speed of Sham? So in above question we found out that speed of the Sham is 10 meters per minute. That means A option is correct. So in this ninth question, Bharat and Srinivas. So Bharat is on top of Srinivas and there is a ground. I'll represent it like this. Weight is defined as vertically downward force. Its value is mg, where the mass is m is mass of object. Weight is a non-contact force. Bharat is standing on shoulders of Srinivas. Both are stationary. So choose incorrect statements. In free body diagram of Srinivas, weight of Bharat will act on Srinivas in downward direction. Actually, Bharat and Srinivas are in contact, so the contact force will act. Normal on Srinivas due to Bharat will act. The weight of Srinivas will act downwards. The normal force will act upwards on the Srinivas due to ground. So these are the forces acting on Srinivas. The weight of Bharat will not act on Srinivas. The normal will act. The weight on Bharat will act on Bharat due to ground. That is the weight of Bharat. That is different thing. And the normal reaction will act on Bharat due to Srinivas. So these are the FBDs of Bharat and Srinivas. So first statement is incorrect because the weight of Bharat will not act on Srinivas. The normal reaction will not. So B option says that as compared to the situation described above, the normal force on Bharat from Srinivas will be higher if both of them present on the elevator accelerating upwards. See, if both of them are in elevator accelerating upwards, so I'll just draw like this. So basically, Bharat is also accelerating upwards then. So if it's accelerating upwards, so the net force on Bharat is actually NBS minus WB, that is the net force upwards, is equal to MA, correct? Net force is equal to mass into acceleration. So NBS is equal to MA plus WB. But initially, NBS was equal to WB. So here the normal was WB, here is WB plus something MA. So yes, the normal reaction will be higher when the lift is accelerating upward. The force between Srinivas and ground is contact force. The force between Srinivas and ground is this, which is normal reaction on Srinivas due to ground, and normal reaction on ground due to Srinivas is also there. So it's a contact force. So C is correct. The force between Bharat and ground is non-contact force. See, the force between Bharat and ground is actually the gravity force, and gravity is non-contact force. So D is correct. So the incorrect statement is A statement. So A is the answer for this question. In 10th question, the first option is that if the total weight of bricks and table is 20 kilograms, this is the table and these are the bricks. If the total weight is 20 kilograms, then the net force downwards due to weight is actually 200 newtons because weight is equal to mg. So 20 into g value is 10 here. So that's why it is 200. So if the total weight of bricks and table is 20 kilograms, we can take this as a system and the weight will be 200 newtons. So the friction between the table and ground is static friction. See, if we are not applying any force in horizontal direction, okay, if the total weight of bricks is this and then the friction between table and ground is static friction. So yes, it is static friction because, let us read the question. Person starts pushing the table horizontally and nothing moves due to friction. So there is a force on this table, normal reaction, which is given in the question, and the friction is also shown, and this is static friction because when the objects are not moving, the friction acting is static friction, and this will cancel out this force due to the person. So A is the correct statement. If the total weight of bricks and table is equal to 20 kg and the person applies the force of 200 Newton on the table, the friction between the table and ground is limiting friction. See, nothing moves, and the total. Okay, the person applies a force of 200 Newton on the table. Now this is 200 Newtons. But the friction between the table and ground is still limiting friction. Yes, it is still limiting friction because nothing is moving. So B is also correct. If action is friction on a table from ground towards left, friction on table due to ground towards left. So friction on table due to ground is this. Friction on table due to ground is towards left, and its reaction is friction on a person towards right by the ground. No. So the reaction is actually this friction on ground due to table. The ground will also experience some friction in rightward direction. So that is the reaction. Nothing else. So C is wrong. So D's net force on the brick is zero. See, as the brick is not moving, that means its acceleration is zero. So F net is equal to ma, second law of motion. So that's why the net force is zero. So if net force is zero, then the objects are in equilibrium. Acceleration is zero. So if the brick is already if the brick was already at rest and it is remaining at rest, that means the net force is zero. So C is the wrong option. So option number C is the correct answer. So in this question, a person goes from A to C and then from C to D. C is the midpoint of AB. That means this distance is D, this distance is also D, let us say. For a motion from A to C, his speed is 10 meters per second. And for the entire journey from A to B, the average speed is 12.5 meter per second. So 12.5 meter per second is average speed, and average speed is total distance upon total time. Now the time taken from here to here is distance upon this speed. So it is D by 10 plus uh, this speed is, let us say, V here, okay, meter per second. So the time here will be D by V. If we can cancel this D and D, then we are getting 12.5 is equal to 2 into 10 into V by 10 plus V. So 12.5 into 10 plus 12.5 V is equal to 20 V. So 125 is equal to 7.5 V. So V is equal to 1250 upon 75. So 25 threes are, and this is 50. So the speed for motion from C to B will be V is equal to 50 by 3 meter per second. So option number C is correct. So in this question, there is a bridge of length 350 meters and the train is of length 200 meters and it is moving with 10 meter per second. Now driver changes the speed of train to 8 meter per second if less than half of the train is on the bridge. So till the train reaches here, this is like 100 and this is 100. So when the train was from here to here, the speed was 8 meter per second. So how much time it will take for a train to move from this green to this red? So this time will be distance by speed 100. And they are saying that the speed is 8 meter per second if less than half of the train is on the bridge. So basically, if the train starts like this here, less than this is the half part, and the train moves and moves and moves, and this is so while the train moves from here to here, the less than half of the train is on the bridge. So this part is moving 100 meters again. So the time here is also 100 by 8 because this distance moved by train from here to here is 100, and in this part while the train goes from here to here, less than half of the train will be on the bridge, correct, less than half of on the bridge. So these are the times 100 by 8, 100 by 8. For this time the train will move with 8 meters per second. Okay, so actually in the 13th question, we will do the 13th question here. So 13th question says that for what duration of the time the speed of the train is 8 meter per second. For this duration, 100 by 8 plus 100 by 8, which is actually 200 by 8. So 100 by 4 is equal to 25 seconds. So the 13th C option is correct. Now they are asking for what duration of the time the speed is 5. Now the driver changes the speed of the train to 5 meter per second if more than half of the train is on the bridge. So from this time here to this time, okay, from this time to this time. So the driver changes the speed of the train to 5 meter per second if more than half of the train is on the bridge. Okay, so the train, okay, I'll just draw another diagram. So this is more than half, and till this point it is more than half. Yes. So if you just focus on the midpoint, actually, right? So it is starting here and it is ending like this. So while it is going from here to here, more than half part is there. And till it comes here, more than half part is there, right? Just before is the train will look like this, and more than half part is on the bridge. So basically, if you focus on the midpoint, it is traveling 350 meters. And the speed in this region is 5. So the time will be 70 seconds. So for 12, what duration of time the speed is 5 meter per second? So it is uh, C option, 70 seconds. See, if you just focus on midpoint, midpoint is moving 350 meters. That means train is also moving 350 meters. And for the speed, with the speed 5 meter per second. So for 70 seconds, it will move. Now the 14th question asks that in above question, for what duration of time the train is on the bridge? So you see the train is on the bridge when its speed is either 5 meter per second or 8 meter per second, like that. 8 meter per second, like this, right? So the time is actually the summation of the answers of above two questions, which is actually 100 by 8 plus, while it is going from here to here, it's 100 by 8 seconds. Then while the train going from here to here, it is 70 seconds, plus while the train is going again from this portion to completely exiting, it is 100 by 8. So you know it is actually 70 plus 25 seconds, so it is 95 seconds. So for 14, option number B is correct. So these are the answers for 12, 13 and 14. So in this question, string is light and there is a pulley, 6 kilograms, and this is 2 kilograms. Blocks are released from rest. 6 kg goes down, obviously because it is heavy, and 2 kg goes up. When the two blocks are crossing each other, 6 kg has traveled more than 2 kg. See, when they are crossing each other, let us say they cross, I can just draw like this, let us say this is 6 kilograms and this is 2 kilograms. So when they will cross, the distance covered by 2 kg is x, then the 6 kg will also cover x. Then the 2 kg will come here and the 6 kg will come here. The distance traveled will be same for both, because see, in the first case I can just say that the length of the string is, let us say, this part A, all right, and I can just say it's A plus x plus this part B. So you know the length of string is x plus A plus B. Now in second case, the string will have this length, and you can see that it will be x plus A plus B again. See this part, x plus A plus B. So that's why this distance covered by this 6 is x and distance covered by this 2 is also x. So A option is incorrect. Distance travel is same actually. So B is also incorrect because it is saying 2 kg has traveled more. So C says that tension in the string is 30 newtons. So let us calculate that now. Let us draw again. This is 2 kilogram and this is 6 kilogram. So let us say this is accelerating downwards with A, this is accelerating upwards with A. The tension in the string is T, like this. So for 6 kg I can write the weight 60 downwards minus T is equal to its mass 6 into acceleration A. Now for 2 kg I can write T upwards minus is equal to 20 kg downwards is equal to mass is 2 and acceleration is a. If we add this, we will get 4t is equal to 4a. 4t is equal to 8a and a is equal to 5. So if a is equal to 5, 60 minus t is equal to 6 into 5, which is 30. So tension is 30 newtons. That means C option is correct. Is the motion oscillatory? No. Why the motion is not? 6 kg will continue to accelerate like this, 2 kg will accelerate like this. So it is not oscillatory. They will continue to move in a straight line motion. This will move down, this will move up. So it is not oscillatory. So D is also incorrect. So C is the correct answer for this question. So in 16th question, block 1, this is point A, this is the block 1. Okay, this is block 1. Block 1 is on a slide. This is slide. Horizontal ground is rough. It reaches point A with speed of 20 meters per second. Block 2 is kept, this is block 2, kept at a distance of 16 meters from point A. If block 2 was not there, block 1 would have split total of 25 meters. So A would have stopped here at 25 meters, its speed would have been 0. So can we just use v square is equal to u square minus 2a. So let us say the acceleration is a in this direction. So 0 is equal to 20 square minus 2a into 25. It would have stopped after 25. So acceleration will be actually 20 into 20 by 2 into 25. So this will be 5 5s are and 5 4s are and this is 5 4s are and this is 2. 8 meter per second square is the deceleration or acceleration in this direction. Okay, now with what speed it will hit the block 2 they are asking. So we got the acceleration. Now can we find the speed here of block A? When the block A comes here, what is its speed? Okay, so can we just write v square is equal to u square minus 2as again. So v square is equal to u square 20 square minus 2 into acceleration is 8 and the distance is 16 now. So this is 400 minus 256 which is equal to 144. That means speed is 12 meters per second. So for option for 16, 12 meter per second, that means option number B is correct. Now the 17th is also related question. 17 says that the coefficient of friction between the ground and block 1 is what? See, when the block 1 is sliding with some velocity, there will be a friction acting backwards and it will be kinetic friction and its value will be mu, which is the kinetic friction coefficient, into normal reaction. Normal reaction will be mg now. See, because this is the normal reaction which is equal to mg and the weight will be downwards mg and these forces will balance out each other. So the force is mu mg in left direction. So the acceleration will be this force upon mass. This is the acceleration. So acceleration is equal to mu g, which is equal to actually 10 mu. If we just use g as 10. So 10 mu is equal to, we got acceleration as 8 meter per second square. That means mu is equal to 0.8. So if mu is equal to 0.8, for 17 option number C is correct. In this question, car starts at 10 am, moves with uniform acceleration 1 by 4 meter per second square, initial velocity is 0 meter per second, 0 meter per second. It accelerates for 2 minutes, that means 120 seconds. This is the time 10:02 am. And let us calculate the speed here, right? So v is equal to u plus at. So 0 plus 1 by 4 into time is 120. So this is 30 meters per second. Okay, and this is 30 meter per second. So now this will move with the constant speed 30 meter per second. It is also 30 meter per second here. Okay, it is moving with constant speed till 10:05 am. That means 3 minutes. That means 180 seconds. And at 10:05 am it decelerates and comes to stop at 10:06 am. So basically it will run for 1 minute, 10:05 to 10:06. At 10:06 it is stopping, so for 1 minute that means 60 seconds is running and it is stopping here, 0 meter per second. So can we calculate the acceleration here? Acceleration will be in left direction and the magnitude of acceleration is change in velocity here, which is 30 plus the magnitude of change in velocity. It is going from 30 to 0, so change is 30 upon in 60 seconds is happening. So the acceleration is actually half meter per second square in this direction, so it is decelerating. The total distance traveled by car in this 6 minutes duration is what? So, can we calculate this distance first for the first part? S is equal to ut plus half at square and u is 0, so it's half into 80 square. Acceleration is 1 by 4 and time is 120 into 120. So, this is 30 and this is 60, so it is 1800 meters. Now, for second part, it is moving with 30 meter per second for 180 seconds. So it is 5400 meters. And for third, we can just use v square is equal to u square minus 2as. So 0 square is equal to u square. The speed here is 30, initial speed. 30 square minus 2 into acceleration is half into s3. So s3 is coming out to be, we cancel this, 900 meters. If you add all this, s total comes out to be uh, 72 plus 9, 81. So 8100 meters, so 8.1 kilometers. So for 18th, option number B is correct. Now 19th question asks that the distance traveled by car with constant speed is what? So it is s2, which is equal to 5400 meters, so 5.4 kilometers. So option number C is correct for 19th. So the question is, this almirah of some mass, and if it is moving, then there will be a frictional force backwards, and it will be constant. This frictional force will be constant because the kinetic friction is constant. And in the first case, let us say he is applying some force 35 newtons, and the acceleration is half meter per second square. So then we have to write the equation: net force in right direction is 35 minus s is equal to mass into acceleration is half. When a person doubles the force, that means 70, the friction will still be F is equal to mass into acceleration will be 4. Now, can we calculate both of these things? Right. So this is the first equation, second equation. Now, if I multiply the first equation by 8, what am I getting? So it will be 35 into 8, so 70 into 4, so 280 minus 8F will be equal to 4M or M4. Okay. So then 280 minus 8F is equal to 70 minus F. So basically 7F is equal to 210. So F is equal to 30 newtons. So F is equal to 30 newtons. We got it now. So if the force is now 55 newtons, then what will happen? So 55 minus the friction is 30 is equal to mass into acceleration. We find mass also. We can find mass also, right? So we'll put this 30 newtons, the third equation. Can we put the third equation in, let us say, second equation? Then we'll get 70 minus 30 is equal to m into 4. So 4t is equal to m into 4. So mass is 10 kilograms we are getting. So can we just in the question it says now the force is 55 newtons and the friction will still be 30 because the kinetic friction is constant, is equal to mass is 10 into acceleration a. So it will be 25 is equal to 10a and acceleration is 2.5 meter per second square. That means option number C is correct for 20.